Hi guys, this is Steph. I had problem number 2e on homework 9. So, the problem said that for all a in G, the order of a is equal to the order of phi of a. So, in other words, isomorphisms preserve order. So, in order to prove that they're equal, we're going to show that the order of a is less than or equal to the order of phi of a, and the order of phi of a is less than or equal to the order of a. And if they're both less than or equal to each other, then that proves that they have to equal each other. So, quick note over here, E is the identity in G, and E bar is the identity in G bar. Okay, so our proof starts with, let the order of A equal n. So we know that that means that a to the n equals the identity. So we apply phi to the left-hand side of both sides of the equation. We know that phi of E is just E bar because that is the identity in G bar. And phi of a to the n, we're going to leave it as phi of a to the n. By homework 9.2b, we know that we could take the exponent and put it on the outside. So if phi of a all to the n power equals e, we know that the order of phi of a has to be less than or equal to n. So if n is the smallest thing that makes phi of a the identity, then the order is n. But it could also be something smaller that's just a divisor of n. So if the order of phi of a is less than or equal to n, that means that the order of phi of a is less than or equal to the order of a. So we proved one direction. We proved this direction right here. So now we're going to try to prove the other direction. All right, so let the order of phi of a equal m. So we know that that means phi of a to the m equals e bar. So we know that by 9.2b, we can put the exponent inside of phi. So we apply inverse phi to both sides of the equation. So that means that we get a to the m equals e. So that means that the order of a is either m or a divisor of m. So the order of a is less than or equal to m, which means that the order of a is less than or equal to the order of phi of a, which was the other thing we wanted to show. So now that we've shown that they're both less than or equal to each other, that means that they must equal each other. And that's it. Hope that made sense.